This lesson is designed to showcase the capabilities of Symbulator. You will be given a circuit that is much more complex than what you usually find in textbooks, and I invite you to try solving it by hand and by means of other circuit simulators and compare that to the ease of solving it in Symbulator. This is the circuit. The question is, find positive values for Vs and Is that will result in 80 watts being delivered by the voltage controlled current source and in 0 watts dissipated in the current controlled voltage source. The answers are given here, just so that you have them handy. Let's see how this is solved in Symbulator. We start by naming the nodes. Ground is 0, then we name the others 1, 2, 3, 4, 5, 6, and 7. Having named the nodes, we proceed to naming the elements, starting with the resistors. R1, we have to pay special attention to the sequence of the nodes because we want IR1 running from left to right, so we define it as R1, 1, 3, value of 10. R2, the polarity doesn't matter because nothing is controlled by it. R3, the same. R4, the same. Now for R5, again we have to be careful with the polarity. We want the current running from right to left, so we define it as between 5 and 3. For resistor R6, we want the voltage drop to be positive on the left, so we define it as between node 6 and 7. Same for resistor 7. We define it as between 5 and 7 so that the voltage drop is positive on the left. Now we define the sources, starting with the independent sources. For E1, the value is Vs, it's a constant unknown. For J1, the value is Is. And then we come to the dependent sources. This is a voltage source controlled by a current. All we have to do in Symbulator is to pass, as you know, the expression that defines the value. So 0.1 IR5, that's a perfect expression. Symbulator understands it with no problem. Now this is a voltage controlled voltage source. Same thing, 0.7 VR6, that's the voltage drop in resistor 6. Now this is a current controlled current source, same thing. Define it using the letter J, and then in the value just 2 times the current in that resistor. And finally, this is a voltage controlled current source, which completes the 4 possible types of sources, of dependent sources, and it's just 0.2 times the voltage drop in the resistor. So if you see this, there is no complication in defining dependent sources in Symbulator. So let's see now how this is. First, this is how I typed it in the text editor. So you go to the text editor, which is an app. You click on the app, go there, and you type the circuit description, just as we discussed it. Then you copy it, you select it and copy, and you're going to paste it between quotation marks and store it in a variable called Sir, or whatever you want to call it. I like the name Sir. Then now run the direct current simulation. If you allow me, I will increase the speed of the emulator so that it's solved faster. And that's it. Now let's solve for Vs and Is. In the custom menu, if you go to F27, you have there already written the solve expression. So you know that you want your power in J3 equal to minus 80 because you want the power delivered being 80 watts, which means consumed minus 80. And then you also want your power in E2 equal to 0. So these are the 2 equations, and the unknowns are Vs and Is. And in terms of constraints, by the way, if you're not familiar with this, check in your calculator's manual the use of the function solve. And the conditions are that Vs and Is have to be positive, that is bigger than 0. So we click enter, and very quickly we get the answer. The current has to be 0.397, the voltage has to be 17.6. Try solving this by hand. If you use Spice, try solving it in Spice, and you'll get a sense of why Symbulator is such a useful simulator and occupies a particular niche.